This video introduces you to the Tinkercad website, and particularly its circuit simulation feature. It also simulates an Arduino microcontroller board, which is very useful for practicing programming and connecting components alongside the Arduino. You'll find it at www.tinkercad.com. Once you see this screen, click the sign up button. You will have to enter your details. Once you have created your account, you will see this screen. Click Done. And it will take you to this screen to teach you how to use its 3D image creation features. We're actually after it for its circuit simulation, so click this Tinkercad logo to return to your home screen. On the left, select Circuits. This is showing past circuits that I have been working on, but yours should be empty at this point until you click Create New Circuit. It will be automatically given a random name such as this one, which I will show you how to change afterwards. So starting with the components list, you can adjust the window size to view more of the components or more of the workspace. So components can be just clicked and dragged out into place as required. These are just the basic ones. Click here to view all available components within the simulator. Or if you're searching for a particular one, such as any type of sensor or a button, you can type up in this area here. So just dragging this down. Components, once they're out in the workspace, can be adjusted with these buttons here. Rotate to any position, deleted. You can automatically zoom to fit the best screen size. And now if I zoom out again using the scroll wheel on the mouse, I can undo my last step, which was deleting the resistor. And here it is again. Undo back to however far you need to go. And I can change the value of a resistor over here. 220. Change it to ohms rather than kilo ohms. And you can see the color bands change to represent the resistance. Red is 2, brown multiplies by 10, so 220 ohms. Okay, so we have a resistor and an LED at this stage. Rather than having them just hover in space, if we open our components window again, you will see there are breadboards available, which I can drag out here. Close my components window, and moving a resistor into place on a breadboard, you can see the terminals automatically line up with the pins. Now, in case you're not familiar with how a breadboard works, as I hover over here, you can see that all the ones that light up green are electrically connected. So by placing this component leg here, it is connected to all of those. So if I also place the LED's leg here, those two are joined together. Now, we are looking at simulation of the Arduino circuit board. So if I open the components window, and you can see the Arduino Uno is listed within basic components. If I click it, drag it out here, I'll just close this window. So I'm just going to change the layout. If I take the breadboard, place it this side, well, it's selected. If I rotate it, I can bring it up to vertical, move it back and center it in the view. Now, these power rails, positive and negative, are used to share out a supply such as this 5 volts between multiple components in a more complicated circuit than the one we've got here. So if I take the 5 volts, click there, drag a wire down to here, the blue lines will appear above and below to help you keep it vertical or horizontal, which keeps the circuit easy to follow when in a more complex circuit. Bring it out to here, click, and it will let me bend the wire to come across to here. Now I'm not perfectly lined up, but that's okay because I can come back to the bend and those same blue lines appear to allow for the wire to look quite neat. I will do the same with the ground wire. Click that, bring it out to click there, which will bend it around the corner and put it in the negative side. And adjusting like that, we have 2 wires alongside each other. Just by clicking them and changing from this drop down list here, I can make it represent the uses of these wires even better, the red for positive and the black for the ground. Now, I won't actually need the 5 volt supply. I can use a digital pin to connect and power the LED. And click there. LEDs are polarized, so it does matter which way around the legs go. The anode must be the more positive side and the cathode must be the negative side. So the cathode running through this resistor to ground, then back through here to the ground pin, and this is a complete circuit from pin 2 around here through the LED, through the resistor, down here to ground. Now it just needs code to allow the LED to turn on. If I click the code editor button, and we'll just drag this window up to make it full screen. This is wiring code that is what Arduinos are usually programmed in, but Tinkercad has a feature that allows for programming using visual blocks in the style of Scratch, similar to Blockly or other visual programming you may have come across. This code here is automatically created to be the equivalent of whatever has been put here. This is just sample code that pops up automatically. Set built-in LED to high, wait 1 second, set built-in LED to low. Now that would work with the built-in LED. Let's modify it a bit to get our LED that's connected to pin 2 to come on and off. If I click to break it all apart, we're going to put that in the bin and that in the bin. We'll keep the timing out here because we'll make use of that. Here are the main 6 menus. Output, we're actually after pin 2. So if we grab a couple of those, set pin to high, drop it down, actually select pin 2 and select pin 2 here. You can see the code is constantly updating every time I change anything here. Connect a delay. So that's turning it on, waiting 1 second and turning it on again by setting it to high. We need to change that to low. Wait 1 second, and this bit of code will loop continuously until we stop the program. As you can see here, it's within this loop. Drag this back down so we can see our board again. Zoom out a little bit with the scroll wheel on the mouse. You can also scroll within this window, or you can click and drag your blocks. To get this simulation started is the Start Simulation button, or you can also upload the code from here and let it run. Powers up the Arduino, and you can see the LED comes on and turns off every second, as expected. So we can stop the simulation by clicking this button. I just want to show you why I've put this resistor in. For those of you who have used LEDs before, you will realize that without this in place, too much current will flow through this LED, and if you'd really connected this circuit without the resistor in place, it will burn out the LED. So let's just simulate that. Connecting across the bridge, and in place of the resistor we've got a short circuit there, and start that simulation up again. And you'll notice while the LED is coming on every second, there's this little info tag popping up. Now there's a message there, but it's not popping up for long enough to read it. So stop simulation, I can edit the code. Let's just make it come on for longer than 1 second. Make it 10 seconds and only off for 1 second. We can either click upload or run or start simulation. It will automatically upload it, the code, if you do that. The LED is on, and if I hover over here, current through the LED is 53.5 milliamps and recommended maximum is 20 milliamps. The usable lifetime of the LED may be reduced. So as I said, it will probably burn out in a real life scenario. So stop simulation, click that, and we can press the delete button on the keyboard, bring our resistor back into place, start simulation. There's our LED on, which is still coming on for 10 seconds at this stage. Stopping that. As you can see, there are plenty more things you could simulate within here. So it's worth having a look through and playing around, because no harm can be done with a simulated circuit, and that is the benefit of using a simulator. So closing the code editor, centering the circuit. You can click here and see a nice tidy list of all the components you've used, which you can then download. Click back to this layout, and if we click back over here, it will take us back to the main screen that we started at. And you probably want a different name to what it allocates you. So the settings button, properties, change it to something descriptive here. Let's call it circuit 1. So we're just saving the change to the circuit board name. There. And when you want to open it again, all you need to do is click Tinker this. And there it is. Another potentially useful feature is duplicate, which when you click that, Gives you a copy in case you have something that you want to experiment with without destroying the original. Once it loads the preview. In future demonstrations we can get it a little bit more complex than just one resistor and one LED, but I'm sure that's enough to begin with and explore from there.